Expansion. This is the expansion of binomial algebraic expressions. A binomial algebraic expression is one which has two terms. Take for example, this is an algebraic expression. It has just two terms, so it's binomial. X plus y2 is an expression with two terms. 2x plus 3y. It has just two terms, x minus y. Let's go to other letters. U minus 2v. 5a plus c, and so on. All of these have just two terms, so we call them binomial expressions. There are two methods of doing binomial expansion. There are two methods we use in carrying out binomial expansion. One, the Pascal's triangle. We use this Pascal's triangle. And two, the binomial expansion theorem. The binomial expansion theorem. Let's take the first one, the Pascal's triangle. Let's take the first one, the Pascal's triangle. Now, in doing an expansion such as a plus b raised to power n, we can use the Pascal's triangle. When n is 0, there will be one coefficient and it's equal to 1. When n is 1, there will be two coefficients and it's equal to 1 and 1. When n is 2, there will be three coefficients and it's equal to, just see this as adding 1 plus 0, 1, 1 plus 0, 1. Here, 1 plus 0, 1, 1 plus 1. I'll write the answer in the middle, 2. Then 1 plus 0 here too, 1. So when n is 3, the coefficients are 1, 3, 3, 1. So you will notice that this is like 1 plus 0, 1, 1 plus 2, 3, then 2 plus 1 also 3, 2 plus 1, 3, then 1 plus 0, 1. So assume there's an invisible 0 here, and you are doing the addition of 1 plus this 0 to get 1. So you already know what the coefficients will be when my n is 4. When my n is 4, the coefficients will be 1, 4, 6, 4, 1. Let me give this some more space. So 1 plus 0, 1. Or let's do it this way, 1 plus 0, 1. Let's assume there's an invisible 0 here. So 1 plus 0 will give me 1. Then 1 plus 3 gave me 4. 3 plus 3 gave me 6. 3 plus 1 gave me 4. 1 plus the next 0, which is invisible here, gave 1. So on and on like that. This is how the Pascal's triangle is formed. So for 5 now, when n is 5, your coefficients will be 1, 5, 10, 10, 5, 1. Let's try and add that. When n is 5, the coefficients will be 1, 5, 10. Let me give it more space. 1, 5, 10, 10, 5, 1. When n is 6, my coefficients will be 1, 6, 15. Notice I'm adding the two upper numbers and I'm writing the answers between them in their middle on the next row. 15, 20, 15, 6, 1. When n is 7, my coefficients will be 1, 7, 21, 35, 35. I'm trying to squeeze it in because I don't have much space left. 35, 35, 21, 7, 1. I think this is how far I can take because of space So this is the Pascal triangle. It goes upwards like that and comes this way. So that's the Pascal triangle. Now 2. Let's go to the binomial expansion theorem. The binomial expansion theorem. The binomial expansion theorem states that to expand a binomial algebraic expression such as a plus b raised to power n, we should use the formula. I'm supposed to write it in front of it, but I'm looking at the space, so let me take a step to the next line. You can write yours in front if you have enough space. It says the first term is n combination 0, a raised to power n minus 0, b raised to power 0. The theorem says the second term should be n combination 1, a raised to power n minus 1, b raised to power 1. It says that the third term should be, all of this should be on the same file, the same string, single line, but I'm looking at my space. The third term should be n combination 1. The third term should be n combination 2, a raised to power n minus 2, b raised to power 2. The fourth term should be n combination 3, a raised to power n minus 3, b raised to power 3, and so on, till you get to the second but last term. That's n combination n minus 1, a raised to power 1, b raised to power n minus 1, plus n combination n. The last term will now be n combination n, a raised to power 0, b raised to power n. This is referred to as the binomial expansion theorem. It may take using it a few times before you master it, but it's very simple to write. Very, very simple. You see how we use it when we start answering questions with it.